Okay, so we looked at objects last office hours. And let's go ahead. I'm going to share my terminal window. And now you can see everything, right?
Mm-hmm.
Okay, so here's my code. I've got a color.hpp on the top, so a color header file, and a color CPP on the bottom. I think we left off talking about
Quick thing. What I'm seeing is for driver for testing the pharmacy functions.
what? Really? Oh, shoot. Oh. Oh, sorry. Okay. Let me reshare. Wrong window. Okay, that should be better.
Yes.
Okay, so we have a color.hpp on the top. And in this, I've got two classes defined. I've expanded it. We had color last week. Now we're going to have HSV color and RGB color, which are just two different formats for describing a color. RGB being red, green, and blue, and HSV being hue, saturation, and value. It's just something to work with. It's not, you guys don't need to know what RGB versus HSV is. Just they're two different ways of representing colors, and you can convert between the two. So in our class HSV color, we have our public interfaces. And in this case, all we have are two constructors. And do we remember what a constructor is from last time? Should we talk about that again?
I couldn't give you a definition off the top of my head.
Okay, so let's quickly go over that. So when you create or instantiate an object, two things are going to happen. The first thing is somewhere the memory for it has to be allocated. And we're going to talk about memory allocation even more in depth in, I think it's the next chapter. But that memory has to come from somewhere. Somewhere these values, this hue, saturation, and value, for example, in the HSV color class, we have 3 integers. So what would that be? That'd be, each one's 4 bytes, so 12 bytes total. Now there is some other overheads with classes, but for simplification purposes, let's say we need 12 bytes because that's how much our private members take up. So the compiler is going to go ahead and get 12 bytes from somewhere. We're not going to worry about that right now. And then it has to initialize that memory to something. And to do that initialization, what we're going to rely on is our constructor. And our constructor looks very similar to a function, but it has no return type. And it has no return type because it's going to be returning, in essence, the type that we're constructing. So it's going to be named the name of our type, which is, in this case, HSV color. This is the default constructor. It's considered the default constructor because it doesn't take any parameters.
Mm-hmm.
Now, this syntax is new. This is an initialization list. And we have sort of the declaration of our constructor, the HSV parentheses. And then we're going to go ahead and add a colon. And then after the colon, we are going to list out all of our private, we could have public ones as well, but in this case, all of our private members, which are 3. And this 0 going into it, you can kind of think of this as the same thing as
Initializing it to 0?
setting it to 0. Yeah, we're initializing it to 0, exactly. That's better terminology than I was using. Equivalent to this would be, should have done this ahead of time. Would be hue equals 0, saturation equals 0, value equals 0. So these two pieces of code are functionally equivalent. This syntactically, this is a little bit easier, prettier. I'm not really sure. I mean, Java doesn't have anything like this, that you could only do it the second way. The other thing about it is you can make sure that your member, so like the class itself is getting initialized before, you know, if you, let's say you're opening up a file handle or something also as part of the constructor, you can make sure all of the parts of the class are initialized before we start doing any sort of other calculations or other processing. But beyond that, these are really equivalent. So let's get rid of that because that won't compile like that. So that's our default constructor. The default constructors are fairly important because this is if something is happening implicitly with the compiler, it's usually the default constructor that's going to be called. If you are doing an assignment and things, if you're doing an assignment, it's typically going to use the default constructor to make sure that assignment happens. There is also, let's see, I don't want to talk about it if Zybooks doesn't mention it. Have you read through the Zybooks, Patricia?
Yeah.
Did it talk about copy constructors? Do you remember? I'm sorry, I'm still putting you on the
familiar. They might have, but it doesn't sound familiar.
Okay, let's see. I'm searching it right now. Okay, we don't talk about it till the next section, so I don't want to talk about it now. All right. Okay, so default constructor. Not all classes have a default constructor. In fact, there's certain times you don't want a default constructor because some of these implicit things happening underneath the hood with the compiler, you wanted to prevent it from doing something like that. An example is there's a particular programming idiom called a singleton class. So you're making a class up that can only have a single instance of it. You can't have multiple objects made off of the same class. And that's one area where you might not want a default constructor because you're going to make sure that nothing can happen in essence by default. That a second one can't get created. Okay. Again, I shouldn't really talk about that right now. We'll talk about that in the next chapter. So not default constructor, a constructor that takes some sort of argument or parameters, I should say. This one, HSV color, is going to take 3. It's going to take the hue, saturation, and value. And again, we're using the new syntax of the initializer list to set these values, to set up or initialize your values to what's being passed in as your parameters. Okay, and then we have now class RGB color, super similar, going to be doing the same things, except now instead of having hue, saturation, and value, we have different interpretation to our data. It's now red, green, and blue. So something that you were asking about, like, well, why are we using the classes and what are they kind of good for? Right here alone, we're grouping the data, right? We're saying that integer red, integer green, integer blue all have something to do with each other. And in this case, the 3 of them make up a color. So that's one reason we're using the classes. The other reason, or there's lots of reasons, but another reason is data hiding, data encapsulation. If you're the user and you have an RGB color and you want to do something to it, like in this instance, convert it to an HSV color, you really don't care how that's happening. You don't want to know what's happening to red to make it into the saturation or value. You only are concerned with the fact that you have an RGB color and you want to get an HSV color out of it. So it's data hiding, it's algorithm hiding. You know, the user only needs to know what they need to know. They're on a need to know basis with the class. So, okay, so our RGB color, very similar to HSV color, except now we have this function convert to HSV. And it's going to return an HSV color. And since this is, there is no reference here, it's actually going to be returning by value. And the reason we're returning by value is because we are actually going to be creating a version of HSV color. If we return by value and if we return by reference, we would be returning a local variable to this function, and it would disappear the minute this function went away, and then we'd be holding a reference to invalid memory. So, so here we are going to return by value, and if we go into our convert to HSV, we start doing the calculations, and I will be honest, I did not finish the calculations for going all the way from RGB to HSV. Somehow I thought it was like 3 lines of code, and then when I got into the algorithm, it was a lot more. But so here's kind of the beginning of it. And now within convert to HSV, we are in the scope of RGB color, and that's shown by having to actually scope the function with the name of the class. So once we get in here, once we're within the scope of this method or function, we are also within the scope of the class. Because we are in the scope of the class, we can use all of the private members defined in the class. So here I'm using my red, green, and blue values. Now, does all of this make sense so far?
Yeah.
Okay. Now let's say we actually want to use it. Now I'm probably going to use it and it won't compile. Actually, it's not going to compile because this won't work this way. Okay, so I'm going to go ahead and compile, and I have my compile line on the bottom, which is g++ main.cpp color.cpp, and then the the executable name is going to be object ex. Okay, so that compiled, and then I can go ahead and run it. Nope. Okay, that's confusing. Let me redo that. Okay, right, quit. Okay. So if I run object exe, it doesn't do anything because our main doesn't do anything. So let us look at our main. Okay. Okay, so I'm going to look at the header file and see what we can actually do. So I know I can create an RGB color, and how would I do that? So I'm going to use the type RGB color, and let's see what I'm going to call. I think we'll call this black because I think by default that's what we would get with the default constructor. And then we'll have an RGB color. I don't know, what's it, let's try teal. And teal will take, it's not going to be much red. Or no, sorry, I think that would be all red. No, no red. Okay, really not important what the numbers are, but so we're making our teal color out of green and blue. Okay, so we've created 2 of these. And now let's see, what can we do with them? What do we need to do? I guess I could convert one to RGB color. So let's just do that for both of them. So we'll say HSV color equals color black. HSV, we can't name it the same thing, is going to equal black dot convert to HSV. And I can do the same thing with RGB color teal. I'm sorry. Want an HSV color. Teal, HSV equals teal convert to HSV. Okay, does all of that make sense?
I think so.
Okay. I think you've totally got it then. So one last thing I should add here is, why don't we have a print? We're going to have a void print. And we're going to need to fill that in our CPP file. Okay. So I need to, so it's a void, and then I need to scope it with the class that's it's from. And then I'm going to say print. And this one doesn't take any arguments because we're just going to use the values that are part of our class. And so I'll just say cout. Let's make this simple. Hue. Sorry, saturation, stat. And this is all going to print on one line because I didn't put new lines in. Val. Oh, yeah. I found the one. Okay. So I'm going to, let's go back to our main now that we've got that print function. Now we're going to say print, sorry, we're going to say black HSV dot print and teal HSV dot print. Okay, we'll X out of this. We'll make sure it still compiles. Nope, I don't have the command line there. All right, G++ main.cpp, color.cpp. Okay. Oh, unknown type. Okay, what did we do? What did I do? Okay, what's my error?
Oh, you have to include the file.
Yeah, I have to include the header file for color. Oh. Okay, and apparently I can't, I don't remember if I did uppercase or lowercase. Oh, okay, so those need to be uppercase. Okay, let's try that again. Oh my goodness, sorry. It's just not to, here you guys get to watch how to. I know. Oh, and the header file too. I mean, sorry, and the other file is actually where I need it. Wrong one. What? Oh. We need our header guards. Okay. Extended. This is useful. What am I doing? Did I not include, okay, so I think this is the real problem. So the header guard's always good. Okay, finally, sorry. Okay, so we're printing out both our teal and our black, and everything's coming out black because everything's set to 0. And that's probably not what we would want, but it's actually what the code does. So let's go look at the code. Okay, so we're printing our HSV color, which is in the bottom there. And really simple, we're just printing out all of the members in the class. And everything's coming out 0 because I, to make this compile without errors, or sorry, without warnings, I simply return an HSV color using the default constructor. The default constructor is going to set everything to 0 from what we looked at in the code earlier. So to make this do something else, and I'm going to ignore what the real algorithm is, but we're going to say to convert to HSV, red adds 255. This is so not true. Green, you're going to subtract 255. And blue, you're going to, we're going to mod by 255. Okay, I'm going to get rid of this algorithm. Okay, so now I'm not going to, here's our make-believe HSV algorithm. We don't want to return the same values over and over again, creating lots of objects that have all the same values. The point of having these objects is that we can store, have the same structure for the data, but the data have different values. So instead, we're going to use the other constructor that takes 3 parameters, and we're going to put our R prime, G prime. And you know what? I don't want to confuse things. So I'm going to rename this. This is going to be our fake hue, our fake saturation and our fake value. And so that is what goes into okay, so this is now going to call the other constructor, the not default constructor in HSV color. So now that we've done this, let us promise it'll compile faster this time. Compile it and run it. Okay, now we got the same thing back again. So what are we doing here? That's, oh, I'm sorry, we did not get the same thing. Okay, so our first object, which was our black, is going to come out 255, minus 255, and 0 because you add 255 to 0, you get 255. You subtract it from 0, you get negative 255. And if you mod it, then you're going to get a return value of 0 because there's no return, there's no remainder. Same thing happens with our teal object here, right? We get 255 because we put 0, and then it was 100, 100. So instead, we now see negative 155. And if you mod 100 by 255, you're going to get back 100. So, so we have our two different colors, our teal and our black, now both converted to HSV, our fake HSV. So, any questions with that?
No.
Okay. So one other thing I wanted to go over that the CISC definitely touches on is inline functions versus not. Now, did that make sense in the CISC, what they were talking about there?
I don't really remember
that. Okay. So they talk about declaring a function inline. I don't think it's like uninline, so it's just not inline. Here, we are actually declaring our constructors inline because the body of the constructor is being declared in the header file. They're very simple functions, so there's no reason not to just leave them in the header file. It's kind of a lot of effort, I guess, to actually go ahead and try to, redefine it down, redeclare it and then define it in the CPP file. You can, there's nothing wrong with that. You can definitely go ahead and do that, but they're simple. So if they're shorter, we tend to want to just put them in the header file so you can just see them very easily, less code to write. And it's also, in the past, it was also a hint to the compiler to say, go ahead and inline this function directly into the code. So these are short little functions that instead of, so do you remember when we were talking about functions, there's the call stack and you have the code jumping around from place to place. You jump to another part of where the code is executing. And then there's a different part of memory where the values for the parameters go to, and then you jump back to the place you were in code before when you hit the return. Mm-hmm. The CISC talks about that in the functions chapter. If you inline a function, so if you're telling the compiler, don't do all of that, this is a really simple function, go ahead and inline it. Just insert that code directly into the code that's calling it. Um, so let's see, what could we use as an example? Let's say for some reason in our HSV color, we want to get the hue back, just the hue by itself. So we're going to create a getter function. And do you remember reading about the setter and the getter functions in the Sci books?
Yeah.
So let's create a getter function. So we'll just say get hue. And again, it's a really simple thing. So return hue. And I just realized this is probably not the best example, but that's okay. So if we go to our main, oops. Okay, so we've got our get hue at the bottom. If we call it, let's say we just call it here. So we're going to inline it. My hue equals okay, so this is definitely not the best example, but instead of calling get hue, what the compiler in essence is going to do is actually substitute all of this and instead kind of just say hue, because we're just returning hue here. It would probably be, that's not the greatest example because if we actually really substitute a review, this doesn't mean anything. But instead of going through the whole call stack just to get the return hue, it's pretty much just gonna substitute in black HSV.hue, right? It's just gonna do something like this. Let us do a better example because I really don't like that. Okay, let's say instead we'll make a function hue plus hue and value. Okay, and we're going to return hue plus value. Okay, another pretty simple function. We're just adding two of the values together. So then if we were to call it up here, I'll just say so H and V is equal to, let's see, black HSV dot hue and value. All right. I don't know if this is going to illustrate it any better, but so if this is our typical function, we're going to go through this whole call stack. We're going to have to find out where in text this hue and value functions to define. The code will have to jump to that location. When we're ready to return, they'll have to get rid of that call stack and jump back to the main code. Instead of doing all of that, the compiler is just simply going to go in and say, okay, we're just going to set that equal to hue plus value. So we're actually inlining it into the code. We're actually almost substituting it, kind of substituting it right into the code. The node jump will happen because instead we're just going to do the operations directly there. You're not going to have to jump to the calling or to the function, and you're not going to have to jump with the return coming back. And jumping is actually incredibly expensive for the processors, so they want to try to reduce that as much as possible. So it's really an optimization. today the compilers are so smart that they will, it doesn't matter where you declare these functions. If it thinks it's simple enough, it will inline it wherever. But it's still kind of a good thing to know. And anytime you are writing a function, some of the rules for inlining versus not is you don't want it to be, I think it's anything that's more than like, I think 5 or 10 lines, you don't want to put it in your header file just because it's going to clutter up the header file. It can't call another function because once you call another function, then a jump does have to take place, so it can't inline it anyway. If you start, anytime too much branching happens, like if you're doing an if for a while, again, a jump is going to have to take place in the code anyway, so you don't get anything out of inlining it. And it actually can't inline it because then the jumps start getting confused. So that's a lot of under the hood information, but that is function inlining. So again, short functions, not complicated. Processing, no whiles, no ifs. If it's just sort of adding, subtracting, multiplying, or your basic operations, then it's an easily inlined function. So any questions about that?
No.
Okay. Okay, so any other questions in the objects and classes, the ZyBook chapter?
I'm sure there are, but I'm not sure of any.
Okay. So if we just, so I was thinking we'll spend a few minutes just talking about the lab. And let's see, where is the lab right at? Okay, so objects lab, learning objectives, class declarations and definitions, constructors, public and private access levels, class members, class member functions, object instantiation, object usage, data hiding and encapsulation. Okay, so I'm sorry for the banal topics, but we're gonna do real estate, yay. So we're going to come up with a, I don't know, mini multiple listing service. So like kind of a mini database that will house different house listings when they come on the market. So several different files. We have, kind of similar with our functions lab, we have main CPP. So this is the driver for our real estate application. So this is where you're going to go ahead and use the functions defined in the rest of the files. Property listing.hpp. So property listing is going to be the object or the class and object we're dealing with. So it's the header file for it, the definition file for it in the CPP, and then some helper functions for kind of coming up with our database that's going to encapsulate our property listings. And then, like we've seen with previous labs, I have a Mac executable and a Windows executable. Similar compiling as last time. Make sure to use the C++11 flag. I think a lot of you have been using C++11 in your code already. ZyBooks does introduce some of it. So make sure you're adding that flag in there. This is just saying, we're not using just our generic C++99. This is C++2011, I think was originally where it came from. Then our dash warn all, and then the CPP files that we're going to be accessing, and then we're calling it objects lab for the executable. So stuff about running it. Okay. So all of these files I have, I think they all have code existing in them already. Maybe not main.cpp. I may make you do that pretty much from scratch. But there's a lot of code already there for you. To complete this assignment, you have to complete the property listing class declaration and definition. Oh, yeah, that's right. So main CPP, the driver is pretty much actually written for you, and it's going to be using members out of the property listing class. So you have to make sure to get main.cpp compiling by defining everything for it. Something I probably didn't stress enough with the earlier labs that have template code, do not modify the template code. If you modify the template code, you possibly are not hitting all of the learning objectives that I'd like you to for this lab. So just don't modify anything. But if you have something that you feel needs modifying or is not right, please email me, let me know.
Is there a way within like code blocks to like basically say to not let you touch those points so that you don't accidentally, like when you start adding your own stuff, you don't accidentally go back to something that was originally there and try to modify it?
I wish there was. I don't know about that. Yeah. You could, I mean, you can always diff it after you're done, and the lines that were there before shouldn't have changed.
Yeah.
The only part should be new additions of the code that you're putting in. Yeah, I can't think of much else other than that. You can always re-download it and use a tool like Meld, but I don't know if you want to start learning new tools. So I think for the most part, you're going to know if you've modified it or not. So well, let's put it this way. I definitely don't want you intentionally modifying it. So, okay. So you need to complete the property listing class, declaration and definition. And then you're also going to need to complete the helper functions in the property listing helpers. And the 3 you need to complete are listed here: the print listings, print maxes, and add listing. I have a couple functions already written for you that you can look at as examples.
So are those just going to be straight writing functions?
Yeah, these are like the functions we did last week.
Okay.
The difference is now you're going to be using objects within it.
Oh, okay.
So the reason I'm having you write these up is the object usage. Not only do I want you writing the class to create that's sort of the template for the object, I also want you instantiating the objects and using them. So that's wherever it went, that's what these 3 functions are going to be doing. Let's see. Oh, okay. So I have a toString member function. Don't write your own print. Don't try to just print out the object some way. Just go ahead and use the toString and print the string that it returns. Partly that's because I want to see the usage of it, and also this will help make things look consistent when we go to the grading phase. So again, don't modify the functional code provided. I don't care if you touch the comments, but I'm not sure. Yeah, if you want to modify the comments, that's fine, because that's not going to functionally change anything. And if it helps you understand it, great. I'll make sure in our functions, we talked about const. Make sure to use const when it makes sense. So when things are not mutable, Again, you want to hit all the learning objectives. If you're not hitting all the learning objectives, something's probably missing. And then our typical zip, how to zip up our files and submit them. Just go ahead and zip all of the files together into a single zip file and upload them. Rubric, so 5 points for just getting the declaration, so the HPP file correct for the class. So you can get, even if nothing else works, you still get 5 points if the class looks good. 5 points for a correct definition. Oh, there's a bug. Five points for a working real estate application. Oh, wow, okay. Five points for other tests. All right, I'll have to upload this again. So 5 points, I'm gonna run it against some unit tests that I have, and if for each one you pass, you'll get a point. So they'll probably be about 5. Okay, 0 points for a project doesn't compile. Even if you have stuff that's not compiling, just comment everything out and submit it so I can see the work you've done. Like a program that has everything commented out will still compile. Let's see, don't want any warnings. I'm gonna dock points if I can see that you've modified a template file intentionally. I'm not talking about like, oh, you're missing a space or something here. It's like you've actually functionally changed it to kind of, I don't want to accuse anybody of anything, but to kind of like get around maybe, you know, dealing with some of the objectives. Let's see. Oh, in this lab, you shouldn't have a reason to declare a public class member. Does that make sense? So we should really be trying to do data hiding and data encapsulation. You shouldn't have any class members in the public space where somebody can just access them like they would any other variable. You have to have getters or setters if you want to actually access the class variables or members. And then again, use the toString method. Don't write your own print function. Don't just, you know, output it in code somehow. Just go ahead and use the toString method. Okay. Any questions on that? Should we look at the code itself quickly?
Sure.
I'm on 3 hours.
Okay.
Yeah. Well, so here's my issue. My biggest
Oh, shit.
is that he doesn't
Okay.
open assignments till that Friday night.
Yeah.
They're due that freaking sun, no, today. They're due Monday, right? Nobody else does that.
Okay, can you see that?
Yes.
All right. So it's going to print out property listing database. Oh, you know what's better than this actually? Why don't I?
I'm sure.
Oh shoot, let me do this. Copy.
And taking classes. Yeah, I dropped from an A to a B because of that crowd.
Okay, so let's run it. Objects. So I'll probably have to. Oh, why am I trying to run the? Oh, jeez, I'm tired. Why am I trying to run that one? That's not going to work. There we go. Okay, property listing database. So we can add a property. We can take a property off the market. We can get an average of all the properties, like the average list price, the average square footage. We can get a max of them, and then we can just list out what we have. So very similar to previous things we've done before. we go ahead and add a property. I don't know, something. Price and square feet. It's a tiny place, 203 square feet. Okay, so if we get the averages, the averages should, oh, do I have a bug? Oh no, that's fine. So obviously our averages, since we only have one, should be equal to whatever that is. Again, the maxes, let's see, let's list the max. Since we only have one, the max should be, well, everything should be that property. If we list them, you're gonna get a listing, and I'm indexing them because, let's add a second one. This one's huge. Okay. So if we list the properties, and we average properties. Okay, now we have an average of the two. And then we can take something off the market. So when we list the properties, you've got the address, you've got the status, which is for sale because we just listed them, the price per square foot, and the estimated square footage. Okay, so I can take a property off the market once it sells. So again, we get that printout of the index related to that property, and you're gonna enter the listing to update. So I'm gonna enter the second one. Okay, and then I'm gonna reprint our listings. And now we can see that our second listing, because I hit 2, is now off market. We didn't remove it from the database or anything, but it's now, the status has changed for it. So if you ever do any database work, you'll find out that you never delete anything from a database. It's there forever. So I'm sorry if your information is up in the cloud somewhere, it's there forever. They very rarely, anyway, so I should go on because this is not a database class, but they very rarely ever take anything out of a database. So, so here we're not taking it out of the database either. We're just going to say it's off the market. Okay, so that is pretty much it in a nutshell. Let's see if I hit 6, unsupported selection, and just do a Control C or D depending on what platform you are on to get out of it. So, okay, so briefly look at the code. Okay, so similar kind of structure we've seen before. We've got our while loop taking our selection. We're going to switch on our selection. This is going to, case 1 is going to be the adding, so we get our input. That's already done for you. Case 2, what was case 2 again? Oh, where you update the listing. And this has been written for you, but what you need to do is fill in the pieces of the class that don't exist right now. So property listing, PL, you're gonna have to use off market. You're gonna have to implement off market. And then we have, for the other cases, we have our helper functions that you're gonna need to implement. And if we go to, if we go to property listing.h, there's not much there. You guys kind of need to fill out the bulk of it. If we go to property listing helpers.cpp. Oh, so I've already, so print prompt was actually being used in there. That's defined for you. Property listings, you need to fill in the code for that. Print averages is done for you. Print maxes is done for you. Or sorry, print maxes you need to do. And then you need to also implement add listings. So that's pretty much it. Any questions with any of that?
So we're not going to be making any modifications to the main?
No, actually, yeah, that's a good point. Main's completely written for you.
Okay, so it's just the remaining 3 files that we're going to be.
Yeah, because you're going to have to touch. Yeah, and you don't even need to do anything with the header file for this function either. I think that should be complete as well.
Okay.
So, yeah, you're right. It's really only the helper's CPP file, so the one we're looking at right now, and the property listing.hpp and property listing.cpp, which is your object, so the class that we're defining.
Okay. Okay, so the 2 for the property listings are going to be our class defining and everything. And what's the helper ones intended for? Just
the helper functions, what are they? So they are used by the main.
okay.
So you just need to fill them out and make sure they do what they're supposed to. And so they should use, if you're not using, your property listing in those functions, you're probably not implementing it how I'm expecting you to. So. Okay. Any more questions with this, or?
No, not yet anyway. Not until I start working on it, I'm sure.
Yeah. All right. I am going to stop recording.